Hello everyone, welcome to Chemotropy learning. So in ongoing lecture series on redox reaction, till now I have discussed about the redox reaction, oxidation, reduction and oxidation number, how to calculate it and how to balance the redox reaction. Okay, so now in today's video we are going to discuss about the redox titration. And you know very well that the titration is a volumetric analysis in which we just calculate the concentration of an unknown compound or solution by using the known compound or substance. Okay, so basically the redox titration is titration in which one reactant is getting oxidized and the other one is getting reduced. Okay, so basically we will find out the or we will calculate the concentration of the unknown substance, unknown solution by the help of redox reactions which is occurring between the two reactants. Okay, so how it is carrying out, it is carried out by adding the standard solution of one reagent taken in a burette to the known volume of the solution of the other reagent taken in conical flask. So how we will just do titration. First we have the standard solution. Standard solution are those solution which whose concentration is known, okay, and that standard solution is taken in burette. Okay, and then the substance or solution which we need to find out the concentration is kept on in the conical flask. Okay, so the solution which is in burette is known as titrant. Okay, while the taken that is taken in titration flask, or you can say conical flask, is called analyte, whose concentration we have to find out. Okay, so now when we just go through the titration process, a stage will come when the two reagents or two reactants will react completely. So how that point is known as equivalence point or end point. Okay, so this end point or equivalence point is get indicated so that we will be able to see something by our own eyes that the reaction has been completed. Okay, so for that purpose, to detect that end point, we use indicators. Okay, so I have given some reducing agent and oxidizing agent which are generally used in the redox titration method. Okay, and we usually do in our laboratory. Reducing agents such as sodium oxalate, oxalic acid, the reaction has been completed. Okay, so for that purpose, to detect that end point, we use indicators. Okay, so I have given some reducing agent and oxidizing agent which are generally used in the redox titration method. Okay, and we usually do in our laboratory. Reducing agents such as sodium oxalate, oxalic acid, ferrous sulfate and ferrous ammonium sulfate, which is very important, also known as Mohr salt. And this Mohr salt redox titration we generally do in our labs. Okay, and oxidizing agents which we generally use are potassium permanganate, which is a very important redox titration reagent. Okay, potassium dichromate, potassium iodate, steric salts and iodine solution. Okay, so these are some reducing agent or oxidizing agent which we use in our general labs. Okay, so now what are the indicators which we use in the redox titration method? So basically the indicators which we use here are very different from the indicators which we use in acid base titration. For acid base titration I will make a lecture series and for better understanding. Okay, so here now the first indicators which we use in redox titration is internal oxidation reduction indicator. So basically this type of indicator have different colors in their oxidized form or in their reduced form. Okay, so they undergo redox reaction in themselves only after titration reaction get complete. So it means that it should have the reduction potential close to the reduction potential of the analyte. Okay, so that's why if the reduction potential will achieved by that analyte during the redox reaction, at the same time this will also get reduced to its reduced form in order to give the different color, and it will indicate the endpoint of that reaction. Okay, so this is how these indicators work. Okay, so the main example you can see over here, the indicator is in oxidized form, will just lose electrons to get it in reduced form. Okay, so in oxidized form they have different color, and in reduced form they have different color. So when they get reduced, they will indicate the equivalence point of that titration. The example of such type of indicators are diphenylamine, ferroin, etc. And I have given an example of diphenylamine, how it works as an indicator. The diphenyl benzadiene, which is a colorless in nature, will get reduced, and the reduced form gives you violet color. So it will indicate the endpoint of that titration reaction. Okay. Now, the difficulty, or you can say the disadvantage of such type of indicator is that they should have the reduction potential close to the reduction potential of that analyte. Okay, if they will not have that closeness in their reduction potential with the analyte, then they will not give the appropriate result or give the appropriate endpoint. Okay, or it will not be helpful in detecting the endpoint by using this type of indicators. So let's example we will take. At potential below 0.73 volt, the reduced form of this indicator is predominant and the solution will remain colorless. Okay, so after or over this reduction potential, that is 0.79 volt, the oxidized form of this indicator will be predominant and the solution will be violet, and hence we can detect the endpoint of that reaction. Okay, so from this we can conclude that the change in reduction potential from 0.73 volt to 0.79 volt will be suitable for using this indicator, otherwise it will not give the appropriate results. Okay, so this was all about the redox titration. Next video we are going to continue with the indicators of the redox titration. We will just see more indicators which is used in redox titration method. Okay, so thank you for watching this video, and if you have any doubt in any of the topic which I have discussed till now, you just comment me, you just follow me on Instagram with the same name, that is Chemotropy Learning, and you can DM me over there. I will be there for you to help you. Okay, so thank you so much.